Hello, my dear students in grade 9. I hope you are all safe and fine. This is a mathematics lecture. We will continue in our lesson, the rational and irrational numbers, or how we perform calculations in math. In this lesson here, this week, we will specify reciprocals and opposites of numbers. What do we mean by the reciprocal of a number or opposite of a number? Number 2, identify reducible and irreducible fractions. Number 3, we will know how to perform operations on fractions. Number 4, simplify or reduce a fraction. Reciprocal or inverse of a number. What do we mean by the reciprocal of a number or inverse of a number? If A is a non-zero number, which means A is a number 1, 2, 3, 4, 3 over 11, this is a number. Then the reciprocal of A is 1 over A. And the reciprocal of a fraction A over B is B over A. So as you can see, A over B is a fraction. To get its reciprocal, the numerator goes to the denominator and the denominator goes to the numerator. For example, what's the reciprocal of 3? It's 1 over 3. Why? Since 3 can be written as 3 over 1. So if you change the places, it becomes 1 over 3. The reciprocal of 7 over 9 is 9 over 7. For example, the reciprocal of minus 2 is 1 over minus 2. The reciprocal of minus 4 over 3 is 3 over minus 4. Now the opposite of a number. The opposite of a positive number is a negative number, and the opposite of a negative number is a positive number. For example, the opposite of 4 is minus 4. So we keep the number and we change the sign. The positive becomes negative. The opposite of minus 7 is equal to 7. So the negative becomes positive. Now, what do we mean by a fraction in math? It is a numerator over denominator. A fraction in math can be reducible or irreducible. Reducible means there exists a common factor between both numerator and denominator, and both the numerator and denominator can be divided by this factor. Both the numerator and denominator can be divided by the same number or the same factor. For example, 6 over 10, 6 can be divisible by 2, 10 can be divisible by 2, so this is a reducible fraction. 15 over 25, we can reduce or divide the numerator and denominator both by 5, so it's a reducible. 8 over 20, we can divide up and down by 4, so the common factor is 4. 21 over 35, we can divide up and down by a common factor, which is 7. Irreducible fractions, if there exists no common factor between the numerator and denominator. 7 over 13, these are prime numbers, no common factor between them, so this is irreducible. 1 over 8, any fraction having a numerator 1 is always irreducible. 1 over 8, 1 over 10, 1 over 5, 1 over 3. Since the numerator is 1, so it's irreducible. 21 over 22, why is it irreducible? Since the numerator and the denominator are successive, or they become after each other's. For example, 5 over 6, 7 over 8, 9 over 10. These are successive numbers or consecutive numbers, so it's an irreducible fraction. What do we mean by a decimal fraction? A decimal fraction is a fraction whose denominator is 10, 100, 1000, or a power of 10. So to know if a fraction is a decimal fraction, I always look at the denominator. 10, so it's a decimal fraction. 100, it's a decimal fraction. My denominator is 1000, it's a decimal fraction. My denominator is 10 squared, which is 100, so it's a decimal fraction. My denominator is 10 cubed, so it's 1000, so it's a decimal fraction. We can perform operations on fractions. We can add fractions, subtract, multiply, and divide. I will talk about addition and subtraction because what applies to addition also also applies to subtraction. Whenever you see two fractions and in between there is addition or subtraction, you should know if the fractions are like or unlike. Like fractions, they have same denominators. So the denominator of the first fraction and the denominator of the second fraction are the same. Directly here, I get the result fraction. Its denominator is as the denominators of fraction 1 and fraction 2. And the numerators, we add or subtract numerators 1 and 2. Then we reduce our result fraction if this is possible. For example, a over b plus or minus c over b. These are like fractions since they have denominator b, so my denominator of the result fraction will be b, and if there is addition, I add a plus c. If there is subtraction, I subtract a minus c. For example, 8 over 9 minus 2 over 9. These are like fractions, so the result fraction has denominator 9. 8 minus 2 is 6, so 6 over 9. Always the result fraction should be irreducible. I can divide both numerator and denominator by 3, so it's 2 over 3. When we have unlike fractions, the denominator of the first fraction and the second fraction are different. Here, first we change the two unlike fractions into like fractions. How do we do this? We multiply fraction 1 by denominator 2 and we multiply fraction 2 by denominator 1. Now we go back to like fractions. For example, 2 over 7 plus 1 over 3. I look at the denominators. 7 and 3, like or unlike, since they are different, so they are unlike fractions. I change these two fractions into like. How do we do this? I multiply fraction 1 by denominator 2 and I multiply all fraction 2 by denominator 1. 2 times 3 is 6, 7 times 3 is 21, plus 1 times 7 is 7, 3 times 7 is 21. Now my fractions are like, so I keep the denominator 21 and I add 6 plus 7 is 13. 13 over 21 is an irreducible fraction. Now we go to multiplication of fractions. A over b times c over d. How do we multiply? Numerator times the numerator over denominator times denominator, but please don't multiply and get answers. Just write them in this way. Why? Let's look at our example. 9 over 14 times 8 over 21. I have multiplication. So I multiply 9 times 8. I write it 9 times 8. I don't write 72. And I write 14 times 21. Now, the numbers in the numerator and the denominator, I see if I can simplify. 9 and 14 cannot be simplified. 9 and 21 we can simplify by 3. 9 by 3 is 3, 21 by 3 is 7. 8 and 14 we can simplify. 8 by 2 is 4 and 14 by 2 is 7. Now 3 times 4 is 12. 7 times 7 is 41. This is an irreducible fraction. This is how we multiply fractions. Now division of fractions. A over b divided c over d. Division should be changed to multiplication. I keep the first fraction as it is. I change division into multiplication and I write the reciprocal of c over d. You still remember the reciprocal? C over d, its reciprocal is d over c. Now I have multiplication. I multiply numerator by numerator over denominator by denominator. For example, 8 over 5 divided by 10 over 3. So I write 8 over 5, division is changed into times. Reciprocal of 10 over 3 is 3 over 10. Now I have multiplication. I write 8 times 3 over 5 times 10. We can simplify 8 and 10 up by 2, down by 2. We cannot simplify 3 and 5. So I multiply 4 times 3 is 12 and 5 times 5 is 25. Please, there's an important remark. If you have a fraction minus a over minus b, it can be written as a over b since negative and negative becomes positive. Minus a over b is equal to a over minus b is equal to minus a over b. So the minus, if it's in the numerator, it can be written in the denominator or in front of the fraction. Let me remind you of the compound fraction. It is a fraction whose numerator is a fraction and denominator is a fraction. A over B over C over D. How can I change the compound fraction to a simple fraction? I multiply the numerator by the denominator, far times far over near times near. So A times D over B times C to change your fraction into a simple fraction. Please solve all the examples given on a draft. Let's perform these. I will solve one example only. Whenever you see such sentences or calculations in math, these are only solved or calculated using PEMDAS. So I ask here, what operations do I have? I have minus, I have exponent, I have division and parentheses. Parentheses is the strongest, so I should start with this parentheses. I change them into like fractions, then I get the answer. Now I start with the exponent. The exponent 2 is even. Here I have minus, it is changed into plus, and the square is given for the 1 and is given for the 3. Now I have subtraction and division. Division is the strongest, and division is changed into multiplication. Now I multiply 1 times 3 over 9 times 2. I divide the 3 and 9 over 3 is 1 and 9 over 3 is 3. Now I get 2 over 3 minus 1 over 6. I change my fractions into like fractions. Then I reduce the result fraction. Please solve these two exercises, solve these two examples. Also, they are solved for you. Solve them on draft following PEMDAS. Please don't forget, we follow PEMDAS. Now, how we simplify or reduce a fraction. To simplify or reduce a fraction A over B is to find a common factor between the numerator and denominator and divide both by the common factor. And this common factor should be their GCD, their greatest common divisor. For example, 24 over 40. 24 and 40 can be divisible by 2. They can be divisible by 4, and they can be divisible by 8. So their GCD is 8, so I divide by the GCD to get 3 over 10. 120 over 80, their GCD is 40, so I divide it to become 3 over 2 is an irreducible fraction. Now let's simplify a fraction with powers of 10. There are two cases. In this lecture, we will study case number 1. Case number 1, you will have a fraction. All the factors in the numerator and denominator are written as a product. They are multiplied together as this. 15 is multiplied by 8, multiplied by 10 to the power minus 1, multiplied by 10 to the power 8. 9 is multiplied by 10 to the power minus 3, multiplied. So this is written as a product. What should we do in this case? We should follow these steps. Change the power of power to 1 power. If you have a power of power, you change it to 1 power. Here, we do not have a power of power. We should write all powers of 10 in the numerator as 1 power of 10, also those in the denominator. So as you can see here in the numerator, we have 2 powers of 10. We write them as 1. Here, I am multiplying 2 powers having same base, different exponents. So I keep it 10, and I subtract minus 1, minus 8. Plus 8 is 7. Now in the denominator, 10 negative 3 and 10 negative 6, it's 10 to the power 3. Now start simplifying numbers of a numerator with numbers in denominator, then powers of 10 together. So I start asking, is there a common factor between 15 and 9? Yes, they can be divisible by 3. 15 by 3 is 5, and 9 by 3 is 5, and 9 by 3 is 3. There is no common factor between 8 and 3. Now we divide powers of 10. I have 10 to the power 7 over 10 cubed. Division of powers having same bases, different exponents. I ask, where is the exponent more, in the numerator or in the denominator? Of course, 7 in the numerator. So I keep base 10 in the numerator and I write 10 to the power 4 up. So my answer now is 5 times 10 to the power 4. 5 times 8 is 40 times 10 to the power 4 over 3. Sometimes we might have a decimal number in the numerator or in the denominator. So first, whenever you see decimal numbers, you should change decimal numbers into whole numbers. How do we do this? We remove the decimal point and we always multiply by a positive power of 10. We count the digits in the decimal part. For example, 1.4 is a decimal number. How can I change it into whole? I move the point, it becomes 4. How many digits I have in the decimal part? 1 digit. So I multiply by a negative power of 10, 10 to the power negative 1. 0.009, it's 9 times 10 to the power negative 3. 0.25 is 25 times 10 to the power negative 2. Let's simplify this. I ask, 0.08 is a decimal number. It should be changed to whole number. 0.9 should be changed to whole, 1.5 should be changed to whole, and 0.03 should be changed to whole. Here we have a power of power, we change it to 1 power, we multiply exponents. Let us start. 0.08, to change it from decimal to whole, I write it 8. How many digits do I have? So I multiply by 10 to the power negative 2. 0.9, I have 1 digit, so I write 9 times 10 to the power negative 1. 1.5, so I write 15 times 10 to the power negative 1. 0.04, I write 4 times 10 to the power negative 2. This is how I did it. 10 to the power 6 is 2 times 3 is 6. Now, as I said, all the powers of 10 in the numerator should be written as 1 power of 10. All powers of 10 in the denominator should be written as 1 power of 10. Of course, you can use your calculator. So I write minus 2 plus 3 minus 1 minus 5. It's 10 to the power negative 5, and I get this. Now I start simplifying numbers. 8 and 4 can be divisible by 4. By 4 is 2, and down by 4 is 1. Now 9 and 15 can be divisible by 3. By 3 is 3, and by 3 is 5. Now 2 times 3 is 6. 5 times 1 is 5. Now 10 to the power negative 5 over 10 to the power 8. Here, if I get the 10 to the power 8 up, it becomes 10 to the power minus 8. So minus 5 minus 8 is minus 13. This is our answer. Please practice these exercises. They are very, very important. After watching this video, please, if you have any question, contact me directly. I miss you all so much. Please take care. See you next week in a new video. Bye.